Yes, welcome. We'll take a look at the most important alkene. You understand? Ethene is the most important alkene, and it is the constituent of many of the cracking products that we use for fuel. Is that clear? Ethene is very, very important. So we'll take a look at the ethene and see how we can produce it. Ethene is the most important alkene and one of the main products of cracking of gas oil fraction of petroleum. We learned about cracking, isn't it? We said that cracking is the breakdown of larger molecular formula organic compound into smaller ones through the use of heat or catalyst. You understand? So when these larger molecules are broken down, what you produce mostly is ethene. Is what? Ethene. And we give an example. This is C17. Can you see 17? It's very high. So when you break it down, you get this one, C8. You get ethene. Can you see ethene? This one is how many? 1. This one is how many? 1. But ethene is how many? 3. Meaning that you produce more molecules of ethene after cracking. Is that clear? Now, how do we produce this ethene in laboratory? How do we produce ethene? First of all, we know that ethene is C2 what? H4. That's the molecular formula of ethene, C2H4. How do we get it in the lab? We get ethene by heating ethanol with excess concentrated what? Tetraisosulfate 6 acid at a temperature of what? 170 degrees. And this ethanol and tetraisosulfate 6 has to be mixed in the ratio of what? 1:2. So you have 1 mole of ethanol mixed with 2 moles of what? Tetraisosulfate 6 acid. It is a two-stage reaction, you understand? First of all, you will form something that later decompose to form the ethane. Is that clear? Is this same 4 or 5? 4. No, it's a mistake. Is it 5? It's ethane. Ethane should be 4. So it's a mistake, please. You understand? This is the formula for ethene. This is ethene 4. You understand? And this reaction is simply dehydration. Can you see that oxygen, water is taken out? You understand? In this ethanol, when you dehydrate it by taking out water, you see the OH goes out with this, so that you have only what? C and H. You understand? And the reaction has to be done in the presence of concentrated what? H2SO4, concentrated tetraisosulfate 6 acid. What are the physical properties of ethene? How do you recognize ethene when you see one? Number 1, it is a colorless gas with a what? Faint, sweety smell. So when you come across a gas that has a faint, sweety smell, but it is still colorless, you suspect that the gas should be what? Ethene. It is slightly less dense than what? Air. So if you keep air and keep ethene, ethene will be on top because it's less denser. It has no action on what? Litmus paper, showing that it is neutral, isn't it? It is sparingly soluble in what? Water. That means it doesn't dissolve in water so easily. It is only slightly or sparingly soluble in water. Caution, in the process of producing ethane, you understand? You need to put the reaction mixture inside a flask. The flask will contain ethanol and what? Concentrated what? H2SO4. You understand? In order to produce what? Ethene. If ethene is produced, you need to insert what we call, you need to insert an empty flask before you connect it to sodium hydroxide, and then where the product comes. You understand? When concentrated H2SO4 and ethanol reacts, when ethanol and concentrated H2SO4 react, what will produce? Ethene. You understand? This ethene that you produce, you need to pass it through sodium hydroxide to remove any impurity. You understand? But you don't need to connect it directly to this one. You need to insert an empty flask first. Because if you connect it, this thing will suck the sodium hydroxide and it will not give you the product you want. You understand? So you need to connect an empty flask first before you now connect the sodium hydroxide. So when the gas passes through here, all the impurities will be taken out before the pure ethene will enter here. That's why we say caution. In the preparation of ethene, an empty conical flask is inserted between the what? Sodium hydroxide. Between the sodium hydroxide and the reaction mixture. This is the reaction mixture. You understand? In order to prevent sucking back of the what? Sodium hydroxide. And what is the function of sodium hydroxide in this place? To remove what? Gaseous impurities. Is that clear? So this is the structure of the production plant. You understand? First of all, you have your what? Reaction mixture. You understand? Connected to what? Empty what? Conical flask. Then connected to what? Sodium hydroxide. Then connected to the what? Where you get your output. So in this reaction flask, you have what? Corn, S2, SO4, and what? Ethanol. When they react together, they produce ethene. That ethene will pass through here, then pass through sodium what? Hydroxide to remove any impurity before it will not enter here, so that you get your pure what? Ethene. You understand? So you connect this empty flask in order that this sodium hydroxide will not be sucked back into the system. Is that clear? So you study this very well. Ethene is the most important alkene because it is one of the major products of what? Cracking of gas oil fraction. You can use it as fuel. Is that clear? So it is prepared by heating ethanol with excess what? Concentrated tetraoxosulfate 6 acid at a temperature of 170 degrees Celsius in the ratio of what? 1:2. So there will be more tetraoxosulfate 6 acid than ethanol. And this is the general reaction. And this general reaction simply shows us that this reaction is actually a dehydration reaction that takes out the water molecule part of the ethanol in order to produce the what? Ethane in the presence of concentrated H2O sulfur. And physical properties of ethane is that it is a colorless gas with faint sweety smell. It is slightly less dense than air. It has no action on litmus paper, and it is sparingly soluble in water.